お待たせいたしました。
Ladies and gentlemen, thank you for waiting. We would like to announce the result of 4th SRF Award winners. Winners will be presented by the President of SRF Construction and Director of Structural Quality Assurance, Inc. Thank you. Thanks to your support, column reinforcement of SRF has reached 10,000 after East Japan earthquake. And in 2012, we started this award. And this is the 4th award winner announcement. We received excellent ideas every time we organize this event. During the break, I examined some of the ideas. They are very well done. Professor Hakuno and Professor Kabinoya, members of the judge, had selected the winners. So let me announce. There are 2 sections, in student section as well as general section. In the student section, we usually give award to 1, but we've selected 5 winners in students sections, but there has not been any excellent award. For this students awards, Hajime Gojo from Tokyo Art University, the student of Graduate University, A Safe, Comfortable Society is the title. And second group of 10, represented by Nanase Kaneko from Kanagawa University of Technology, Safety, Equal Security, supposing epicentral earthquake strike in Tokyo. We have a group of 3, represented by Hiroyuki Takagi, who is a student of Kanazawa University. Sign of Security is the title of the research. Shoko Hirasawa, she is an individual, the student of Musashino Art University. SRF and cardboard are used for stabilizing furniture. And last award winner in student sector is Rika Takahashi, Capital Tokyo University student, building mutually helpful relationships. Now we have a group of 5. The ground winner is Hiroyuki Egami. He's a student of Sojo University. The title of the research is Flexible Light SRF Reinforcement for Wooden Structure. So I'd like to move on to announce the grand prize winner. President Igarashi, thank you so much. Now we would like to present the certificate and the prize money. Representing the grand prize winning group, I'd like to invite Mr. Kosuke Ota. Please come forward. Certificate, the grand prize. Fumiyuki Egami from Sojo University at Nakazono campus. Kosuke Ota, Gozen Cho, Taiwi Jin. You have shown a great performance on the 4th SRF award winning selection, President of SRF Construction. Congratulations. This is the prize money.
太田様、おめでとうございます。どうぞお席へ。
Thank you, Mr. Ota. Please return to your seat. Next, Award of Excellency should go to the group represented by Mr. Honda. I should make the announcement of winners in general section. I'm sorry, I interrupted. I would like to announce winners in the general section, starting with the runner-up. We have 6 prize winners out of more than 70 applications. We did not find any work that is equivalent to grand prize, but we have 2 excellency winners. The first runner-up award goes to Junji Tezuka, structured redevelopment. The second, Kite Paku from Pandu Inc. Escape Desk is the title of the research. Thirdly, Kohashi Mitsuhashi from Takenaka Constructions. AI vending machine network for safe and secure society. Junshi Yoshida. Title is housing that is resistant to tsunami. 5. We have a group of 2 represented by Kei Hayashiro, the major walls in Kunosho district. Number 6, Terumi Fukuoka, simple evacuation shelter around Tokyo Station. As I said, there is no grand prize winner in this section, but we have excellent works. So we have 2 excellent award winners. First goes to Takeshi Honda from Honda Takeshi Architectural Office. Message Zebra is the title of the work. Another excellent award goes to a group of 3 represented by Shota Ikeda, who are working for Tri-Milai. The title is Usual Comfort and Response to Emergency. Now I'd like to invite the excellent award winners, starting with Mr. Honda. Please come forward. Certificates, Award of Excellency, Mr. Takeshi Honda. You have displayed excellent performance at 4th SRF Award Selection. Igarashi, SRF Construction President.
This is a prize money. Congratulations.
本田様、おめでとうございます。
So once again, congratulations. Next is Mr. Ikeda. So this is a certificate. This is Award of Excellency, Shota Ikeda. Congratulations. This is a prize money. Thank you very much. Please go back to your seat. Thank you very much, Mr. Igarashi. And we will have the presentation from the award winner later. But before that, we'd like to take some time to get the feedback by Dr. Kabeyasawa. Well, thank you. So I hope that I have a list of the award winners. So now, from Tokyo University, the Earthquake Research Institute, Dr. Kabeyasawa, to give us a feedback. Well, this time, I think I will be able to hear the presentations from each presenter, so I don't have to go to the contents or details about the project. Well, maybe I may not go deep dive about the project content, but rather I'd like to focus on how we were screening and came to conclude those three winners. I think the deadline was January, the end of the January, and right after the deadline or due date, we have received the project materials, and at homes, I kind of read quite hard. And back then, we had a gut feeling that maybe we could come to the short list. And on the 6th of February, there was an earthquake in the southern part of Taiwan. And Dr. Hakuno also did his effort. But myself is in charge of the committee, the chairman of the committee in this Architectural Institute of Japan. And I need to do some back office work and trying to communicate the disastered area. And we were kind of sending some staff members to do some research, and we have to get the approval. Well, the 17th of February, I think we contacted. And that was just before this selection time, and I was quite busy because of the earthquake in Taiwan. Well, prior to that, I already had kind of decided or determined who is going to be the winner. But anyway, I was quite busy. Well, two projects are related to the evacuation, and the other grand prize, the other one, grand prize, this is really a high-level project. Well, if we compare against the other years, I think this grand prize winner really produced great project results. As a research, I think this is really great as research. It's really deep or in-depth content in the project. Well, at the usually or ordinary research, you always have to deal with a different validation, verification, and I think, but this winner really went through those validations or verification, and I'm sure that that was quite big work. I put the number of the pages, well, so many pages in the project, and I was actually kind of stuck with those many pages project. Well, the project material is really, really heavy. So maybe sometimes I think maybe we were considering maybe we should put a certain limitation or constraint in terms of how many pages they can produce in one project. Well, this is for the general project applicants, and usually it's within 4 pages. And the one in yellow is the one, the winners. Well, the compact project materials have won the prize. So maybe I want to emphasize, even though you have so many pieces in the project, it may always not be the good ones. Well, in case of students section, this is really a kind of problems. Maybe I should not say this, but this could be a problem. Well, this one is a grand prize winner, and again, this is really in-depth project. Well, I think, but still you can improve to make it shorter, less than 8 pieces. So maybe from next time onward, you can actually have the requirement in terms of the maximum number of the pages. Well, I now can say that even though the project material does not have a lot of pages, they can win the prize. So I think the details can be discussed later, so I should not touch upon too much about the details, but that completes the feedback from myself. Thank you very much. So now we'd like to move on to the presentations by the winners, so please be patient. We are going to set up this stage.
Thank you for waiting. This is the presentation from the winners. First of all, from the student section. From the student section, one award of excellence was selected, and that was given to Mr. Kosuke Ota. And he worked on the combination of SRF and also magnesia combinatory material to make the fireproof and yet earthquake-resistant wooden structure. Good afternoon, ladies and gentlemen. Thank you very much for giving me the opportunity to share my study. And I am working for Egami, Funatsu, Jin, and John, and Ota are the member of this study. Egami is the leader of this team, and he is not able to come here, so that I would like to give the presentation on behalf of the leader of my team. Now, I'd like to give you the flexible SRF and the magnesia combinatory material to produce fireproof, earthquake-resistant wooden structure. In metropolitan area, we have many high-rise buildings. 1923, we have a great Kanto earthquake, and also that caused the massive fire. And still, we have the wooden old structures surrounding the center of Tokyo. In Kanto earthquake time, a tremendous amount of number collapsed, but yet the fire caused much more devastating damages to the people. At this moment, we still have a densely populated wooden structure area, and when fire starts, you cannot really stop or prevent the expansion of the fire. Therefore, we think of the wooden structure can give a pleasing appearance, aesthetic appearance with the agings, and we try to come up with the methodology to prevent them to being easily burned by the fire. By having the high-rise buildings, we can have space between structures so that the fire does not expand, but at the same time, people can enjoy wooden structure. And as for the public structure, the Ministry of Agriculture and then Fishery and Forestry introduced a policy to increase the number of wooden houses and structures, so that now we will be able to construct buildings with more wooden materials. And when it comes to working for the sustainable future, we decided to use byproducts of production of salt from the seawater, so that we can make the wooden structure as fireproof. The wooden structures usually damaged by the earthquake and densely populated area, usually the fire breaks out. And by combining concrete and an SRF, wooden structure is cladded by the SRF so that it becomes more earthquake resistant. And the byproduct of salt or bittern, when you use the seawater, then with bittern you can make a magnesia combinatory materials, so that can improve the fireproof ability and also anti-seismic characteristics of the membrane. So some of the phenomena caused by the epicentric earthquake can be prevented by this type of structure. SRF has binding capabilities, so that even a wooden structure can be contained in a certain movement. And because of the inappropriate construction method that cause the damages, but in the area of a combination or intersection of the members, you can use magnesia so that you can retain the major connection line of the structures. The conventional concrete cladded by SRF is applied for wooden structure, and also the SRF cladded concrete or wooden structure can be combined with the magnesia, so that the wooden structure and also the white concrete are combined, so that you can have a warmth feelings. And also you can have the modern and also classical very good structure with SRF belt. I propose two types of method. First of all, the steel angle is fixing the SRF to wooden frame. This is for the augmentation or supplementation model for the existing wooden structure. Left-hand side is the design of the wooden frame, and right-hand side is the detail layout of the wooden pillar. And for the wooden beams, you can cover the beam with the SRF, and when the member of the house's structure becomes fatigues, and you can apply additives and fix that member with wooden screws. And the right-hand side is the new structure. When you cover this wooden pillar with SRF, then after that use wooden screw and also metal screws to fix the beams and members. And we can diversify the way of method in according to the structure, and by using magnesia you can improve the fireproof capabilities of the structure. By using SRF you can make this earthquake resistant structure, and in case of densely populated area, magnesia material can be used. And earthquake resistant and fire resistant areas you have to cover and then paste with magnesia bonding materials. By doing so all over the structure, you can even have the higher story building. This is the structures using the SRF belt. It is almost like a cave, and people can enjoy the mysterious atmosphere. And it is almost like trees are growing into the sky. The wooden structures go up into the sky. The fireproof and an earthquake-proof structure and also materials are checked at the labo. First of all, we used the compression strength. This is the structure of the AMSRA compression testing machines. And the left-hand side is a breakdown of the structures. And we provide pressure with the machines and then looking up the actual load on the samples. And we compressed the samples up to 1/10 of the original size. The members are all cedar, and also the diameter of the cedar is the SRF 450 can be cladded onto the diameter. Therefore, we set the diameter as 150 millimeter and the length is 300 millimeter. This is how we conducted the test. The sample is wooden, timber, and another type of sample was the wooden cladded with SRF, and another one is wooden plus SRF plus magnesia bonding material. SRF 450 cladded wooden. This is fixed with the screws, and SRF and the magnesia is over 0.8 kilograms per square meter, and the thickness is of 0.5 millimeter constant. And to gain more adhesiveness, SRF 450's claddings pressed, compacted by the hammer and make it stronger. And at the end of the belt, we fixed it with a screw.
SRS 450 is coated. We would leave it for some time in order to achieve high level of adhesive at 15 degrees in room temperature for about a week. Left-hand side, we have wood sample. There has been shear destruction. But for wood plus SRF, on the outer side of SRF, and also the sample on the right, thanks to binding force of SRF, shear destruction did not occur in both of these samples. The upper photo indicates before the experiment as compared to after the experiment at the bottom. The first sample with Hudalan, there is shear destruction to a large degree, but for SRF protection applied to number 2 and 3, thanks to SRF protection, major destruction did not occur. Using SRF belts and magnesia aggregate coated, we have been able to improve performance. So we examine stress reduction rate curve. Blue is sample number 1 of wood alone. Green, number 2, wood plus SRF. Red line is sample 3, wood SRF plus magnesia aggregate. Contraction is only 1% in the beginning. So initial rigidity for every sample is very similar to each other. The maximum stress is indicated here. Red line number 3 compared to blue number 1, that is 1.13 times higher. If you use wood with SRF coated with magnesia aggregate, we have higher resistance to compressive stress. Next, this is the performance test for fireproof capability. We use these experimental devices to carry out combustion tests. On the left-hand side, we have this diagram to indicate gas burner, which is the source of fire. We set a sample 170 meters away from the measurement point. At fixed time interval, we measure the surface temperature as well as the temperature on the backside. This is how we prepare the sample pieces. First, we have plywood of 28 millimeters thickness. This is cut into pieces as big as 120 square millimeters. We apply adhesive on the surface. In order to strengthen adhesiveness, we apply SRF belt, and we also hammer the surface. As soon as adhesive is hardened, we apply magnesia aggregate. This is the video of our experiment. On the left-hand side, sample is just wood. On the right-hand side, we have wood plus SRF plus magnesia. If you look at the left-hand side, the combustion starts much earlier, but for wood SRF plus magnesia, there is no change due to combustion. Magnesia aggregate can withstand the temperature as high as 1,000 degrees, and there is no deformation and much less thermal conductivity. As time elapses, as you would see on the left-hand side, substantial and considerable change takes place due to combustion. You would see the plywood started to burn, but if you look at the combined sample, you wouldn't see any change visually perceived due to combustion. Based on the refractory standard, we continue to apply heat for 20 minutes continuously. The time interval of temperature measurement from the beginning, every second for the first 1 minute, and after that, we do take temperature every 30 seconds on both sides, the front surface and the rear side. On the back side, we do take temperature every 22.5 minutes. We extinguish the fire, then we also take the temperature for 2 minutes. Wood plywood has severe damage due to combustion. The burning was observed in the depth, but if you look at the combined sample, you wouldn't see a major change caused by combustion. This shows the surface temperature of this heating test. This is the frontal surface temperature. Sample B red is 233 at 1 minute, blue 237. So apply magnesia aggregate to B. As you can see, compared to A, borderline, the temperature increase is much slower. When fire is put out, you would also see the temperature trend. The sample B with SRF magnesia would start to lower the temperature, start to cool down much faster than wood. Now this is the real surface temperature. Sample B, temperature increase is 1 degree per minute, but A has increased 4.7 degrees every minute. So apply magnesia aggregate. The thermal conductivity is only 1/3 compared to sample A, thus having higher fireproof performance. On the right-hand side, we have combined wood SRF magnesia, and this shows the exfoliation. On the right-hand side, you can see how it's been protecting the internal area of the sample. Every day, as we lead our daily life, we would realize how we are protected by architecture. Great East Japan earthquake and Hanshin Awaji caused a major death toll and casualty. Not just being able to prepare for disaster, we try to construct architecture that is useful and protective in case of emergency. With that idea, we try to use flexible SRF belt as well as magnesia aggregate so that we can actually protect a wooden structure that gives us a sense of warmth throughout our daily lives. Wood is a natural material. Internally, we understand warmth spread, and when it ages, the value of tradition presents itself, and that is a major strength of wooden structure. I believe that is going to impact the whole community. Light and flexible SRF plus magnesia aggregate being applied, we will be able to protect warm traditional wooden structure to enhance the security of the society. Thank you. Thank you for your listening.
太田康介さん。
Thank you, Mr. Kosuke-Ota. We would like to entertain questions on this presentation. If you have questions, please raise your hand.
Talking about Gaina, do you know Gaina? No, I don't know. Okay. Well, it's a similar insulation material. It's quite similar. So yes, we have a president from the company. So maybe I want you to try using Gaina next year. Well, you don't really have to try because Gaina is already a proven product. You are actually using the materials, trying to show the good features, but when it comes to the structure, the binding or joining part is really important. So not just using the better materials, but how you are going to reinforce the joint for the tensile strength. So as a structure, I hope that you can also validate for the next time. Thank you very much. Any other questions? Thank you very much, and thank you very much for your great presentation. Well, talking about the magnesia, how did you come to conclude using magnesia as the aggregator? And also, without wrapping SRF, but just using magnesia to go through the testing or validation? Well, regarding how we come to conclude using magnesia aggregator, well, in the previous year SRF award, from the same lab, our senior also won the award, Shell Chorus, which is actually using the concrete, using magnesia and shell. So from that experience, I already had the knowledge that magnesia is really great material. Also, it can go up to 1,000 degrees in terms of the temperature. And also, you see there is a kind of a slight moisture or humidity in that magnesia. So that's why the light limestone, well, it has a certain anti-fire or fire resistance. And that's something which we already heard from the seniors. So by combining that magnesia plus SRF, we thought maybe we could produce a highly resilient structure. What's the next question? So just using magnesia, and did you test just using magnesia without having the SRF? Talking about only wood? No, without SRF, just magnesia only to see the testing for non-flammability? Well, we are only using plywood, wood only, and also the combination. So we did not go through the testing, just using magnesia. Maybe the comparing a magnitude 3 could be quite interesting. Yeah, that could be true. Thank you very much. Any other questions? You were talking about it's really good, but I don't remember much from the last year's award. But shell, how you process shell? Not dumping or throwing shell away, but I think they are trying to reuse as much as they can. So that's why you are using the shell. But do you think this you are using shell because it has good fire-proof attribute or property? Well, yes, we may have better material or better combination. Well, yes, trying to find the best one, that's one way, but thinking about what do we do with the shell, that's another thing which you may be able to explore. Yes, the reason why we were motivated to use magnesia, the bittern of the shell or the component of magnesia was also researched at the same time. And just like the plaster, well, I think maybe it can also has a certain moisture or humidity, and and also we were already experimenting and testing that it has a certain fireproofness. So that's why I hope that I answered to your question. Thank you very much. Well, thank you very much. And I think now it's time to close this presentation. So now, thank you very much, Mr. Ota, and once again, congratulations. Well, we'd like to move on to the next presentation. We are going to set up the stage, so please be patient.
それでは続きまして、
So next, we would like to move on to the next presentation, and this is the Award of Excellence. First, Mr. Honda. The theme for this project is Mrs. Zebra. And the next person will be Mr. Ikeda. Yeah, Mr. Ikeda's project is the arrows, which is offering the ordinary comfort and helping the safety. My name is Honda from Honda Takeshi Architecture House or Office, and thank you very much for giving me this great opportunity to make the presentation to you. Well, SRF Award, I was actually walking, thinking about SRF Award, and I investigated a little bit. And the evacuation area around my office, I came to understand where they are. So if I'm office and hit by the earthquake, I know where to go for evacuation, and this is thanks to this SRF. Well, this is my project. Prior to this project, I want you to get one image. Let's say in Misaki-cho, Misaki Town, here in this building, now we are hit by earthquake. Where do we go? Where should we go? Please imagine that happen. Actually, I went to the high school and university within this area. Well, maybe I try to go to the station to find something new, or maybe Tokyo Dome, or maybe the park, or maybe the high school. So maybe I should go toward north, maybe. But as I walk, I think I should get the list of evacuation area. Well, I am sure that around the station, people go to the station, or maybe people are coming down to the station because they can't go anywhere by train, or maybe JR train truck, elevated train truck, railway is there. So maybe there are some other places. Well, from here to the evacuation place, you go to the north and walk for 10 minutes. Kanda Hitotsubashi Junior High School. That's the evacuation place or shelter place. Well, maybe I thought there's one specialist in this room, and taking all of you to that specific place, that could be one option. But if you see people going or flowing into the station, but still trying to bring people to the other location, that could be quite difficult. So I think we have to think not having one specialist, but many people have a certain level of the information and knowledge. How can we allow people to have a certain knowledge and information as to where they should go when they are hit by a major disaster? So I came to pay attention to the zebra crossing. Well, maybe the business people or pedestrians, regardless of gender, nationality, and the age, I think whenever you see the signal showing red sign, then you stop. And during that time, you do nothing for maybe 10 seconds when you are waiting. And during that 10 seconds, if you get certain information, or if you have certain enhanced information about the disaster, how should we allow it to happen? Well, when I'm waiting to go across the zebra and I look down, maybe I can actually find some errors where I should go, and also maybe the name of the shelters, and also how distant it is. Whenever I go to the office, when I stop at the signals, I can always find where I should go just for 10 seconds. Maybe for the day one, you may not remember, but maybe 1 month or 6 months, you get to understand and you get to memorize where you should go when the disaster hits. Well, this display is like if it's a tsunami expected area, I think it should show the higher place or elevated place.
The previous speaker mentioned about the fire and also densely populated wooden house structures, but you can also guide them not to go towards that area by showing the arrow, and also the people who are in the area of the wooden structure, you can also guide them to go outside of that area by showing the arrows. Another point, so-called inbound 20 million tourism promotion campaign is taking place. So towards 2020, we will be having maybe closer to the 30 million inbound tourists. The travelers do not visit the same place many times, so they do not know the area, and when the disaster hits them, you must be able to guide them to a safer area. And I think that this display can help you. 5 years passed since the earthquake, and they come. If you put your shoe in the other side around, like you bring your family to Sumatra, or you bring your family to some earthquake or tsunami afflicted area, and you may feel some concerns. So if you go to a cross section with signal, then at least you can get this information to evacuate. I think that this would be making the Japan as the tourist-friendly country. So I call this message zebra. Two functions. When you wait for a signal to change for about 10 seconds, you would know that's where to go for the emergency. And also, when you happen to be on that cross section, then you are guided to the safer area. And you can prepare this. The earthquake may take place in 6 months, 1 year, but you can do this right away. That's it. Thank you.
本田さん、どうもありがとうございました。
Thank you very much, Mr. Honda. Now, moving on to the question and answer session. If you have any question, please raise your hand. Do you make display in only Japanese? Name of the shelter is written in English. Please show the PowerPoint. And the distance is in Arabic numbers and also arrows showing the direction. So minimum information, but universal information. Thank you for your question. Any other question?
それでは他のご質問がないということなので、
If not, then congratulations once again, Mr. Honda, and thank you for your presentation.
それでは引き続き作品
Moving on to the next presenter. Please wait for a few minutes. Next presenter is Mr. Shota Ikeda. Good afternoon, everyone. I'm working at the Torai Mirai Corporation. Thank you very much for giving me the opportunity to share my ideas with you. Well, my previous presentations were so sophisticated, so my presentation would be rather simple, so I hope you will not be surprised. Well, the title is the regular comfort and also to use arrow to help people to the safer places. And I think my previous speaker's idea was very similar to this. It's very simple. 4 directions and then 2 directions, only one road, 2 direction of the arrows, but in case of a cross section, 4 directions. So please imagine this display as the same as manhole. And I want to use this for the guidance of the people, walkers, pedestrians. To protect people in Japan, I want to make this as sophisticated as possible. So I'm thinking of using LCD panel for this and high-tech display. So this is not just for the evacuation, but also this is for the guidance. It says Fukuoka Municipal Museum, and when you use LCD, you can change it to English or Chinese. So when the, let's say, big exhibition is taking place, then you can guide the visitors from the station to that museum. I'm involved in the city planning, so I realized that these conventional tools are very useful. This was the Chikushino city of the Fukuoka, has Futsukaichi city. This has 2 stations of 2 different trains. But when you walk, they are close. But it's in the old town, so sometimes it's difficult to go to the other station. And local people annoyed that so many people usually ask them which way to go. So they decided to show the display on the road so that they don't have to be asked by the pedestrians. So on the crossroad, cross section, you can find the display, but also we have this on the road. The older people making use of this display. This was a time when the Kyushu National Museum was made, and also this Futsukaiki city was the station for the many visitors to come down. So when it comes to disaster management, when tsunami takes place at midnight, what's going to happen? So this is LCD, it can light, and arrow can be lightened. And even though outage is taking place, if you go outside, then this lighting can be helpful. And also, if you just follow the lighted arrows, then you can reach the shelter or evacuation place. But when tsunami warning was issued, then you really have to be away from the source of tsunami, such as rivers and also the ocean. So by manipulating the arrow, you can help the evacuees. Even though you are told that your evacuation area is a primary school nearby, but you have to go cross the river. You have to go walk on the bridge. And lots of torrential rains takes place in Kyushu area, and it is rather dangerous to go walk on the bridge. So if that is the case, you should guide people away from the rivers. So if you instinctively know that just follow that red light, then you can be saved, then that will be very helpful. And what about the dangerous areas? Let's say that a huge fire is taking place. Just recently, G-space information related services started, and this is the stationary satellite can give you the very precise, accurate GPS information. So when cars are really stuck in the traffic jam, then that first responders should avoid that road.
You know, people have smartphone and applications. This is what Disaster Prevention Research Institute of Kyoto University is doing. From the quasi-zenith satellite, the application will start up as soon as the tsunami warning is issued, and it's connected to this satellite. In case of emergency, you would question whether the smartphone is really available. Can we keep using the smartphones? Is it going to be connected? The internet connection may not be available. For that, we have to have independent function from the internet. I mentioned earlier that LCD panel will light up. What happens if the power supply is stopped? In that case, we could actually embed rechargeable battery inside the panel to continue to indicate the correct evacuation routes. And actually, we can indicate where the national museum is, and it's quite useful at peacetime as well. If there is a soccer Japan Championship games, we could also sort of guide the audience in different directions to avoid excessive congestion on the road, on the streets. And also this could be applied to the disaster drill to enhance the quality of the drill itself. Thank you for listening. Thank you very much, Mr. Ikeda. Now we would like to open the floor for questions. If you have questions, please raise your hand. No question? If not, we would like to close Q&A. Mr. Ikeda, I'd like to thank you so much. This is a great idea. I hope that this is going to be fully utilized in case there is a next disaster striking us. We would like to take a 10-minute break. The third program will start at 20 after 4, 4:20.